Okay, welcome you all for today's class. In this class, we are going to start with the Otto cycle. It is the second class for Otto cycle we are going to discuss. In the previous class, we have discussed the processes involved in the Otto cycle and the PVTS diagram to draw based on the process involved in that. From that, the general efficiency of how to have an efficiency in general, and for an engine, how to have it. Those kind of things we have done it. And here efficiency can be defined by obtained by input. It is the input is here, heat energy supply. Okay, and we have already done it. W obtained is nothing but QS minus QR, and QS or QR is equal to mCV into temperature difference T4 minus T1, as well as QS, that is the input, we have mCV into T3 minus T2. These things we have studied in the earlier classes. From that, we have an equation called the Otto cycle efficiency. So in this Otto cycle efficiency, we have only one term, 1 minus 1 by RC power gamma minus 1. The gamma already got this parameter called adiabatic index. Okay, in adiabatic index, the value of air for air, the adiabatic index gamma is equal to 1.4. That is Cp minus Cv, which is equal to R. Cp by Cv is equal to gamma. Okay, and now we are going to look on the particular parameter called RC, that is compression ratio, because compression ratio is the one and only parameter which impacts or which reflects the efficiency whether increasing or decreasing. If the RC value is higher, that is the significance of compression ratio in the Otto cycle. If the value of compression ratio is higher, what will happen? If it lower, what happens? Whether it does not mean affect the Otto cycle efficiency. That is my question. Okay, but if you put on a value of RC 5, okay, you have a value efficiency. If you increase the value, whether you will get the same value or whether it will go down or it will be increasing. Okay, just check it. But compression ratio is the parameter to give the value of efficiency is higher or lower. Okay, I will tell you when the compression ratio is increasing. Okay, compression ratio is increasing. The efficiency of the Otto cycle also increasing, and vice versa. It means if it is decreased, it also increases. Okay, so compression ratio increases, Otto cycle efficiency also increases. If it decreases, Otto cycle efficiency also decreases. First, we should look on the what compression ratio means. That is the thing in today's class we are going to discuss. Okay. Now I just a bit of everything. I have given a PV diagram here. So compression ratio generally it can be defined total volume of the cylinder to the clearance mode. Total volume of the cylinder to the clearance volume. So total volume of the cylinder means the air is occupied inside the cylinder. Okay, that is the total volume of the cylinder to the clearance volume. So there will be a small gap between the target TDC to that gap. Okay, because if there should be a gap, because it is necessary to provide the gap, otherwise it will hit on depth and wear and tear will happen. In order to avoid that one, a small gap will be provided for that. So the inside the gap, the amount of air occupied is called clearance volume. Okay. In this diagram, PV diagram, we already have. So the processes based on the process PV diagram has been done here, but it will be done some gap. Okay, this is the thing I told you. In that gap, how much volume is occupied? That gap, that volume is called the clearance volume. That is VC. Okay, and This is the process, the volume occupied throughout the process. Okay, throughout the process is called Vs, that is stroke volume. Okay, so this total volume of the cylinder is nothing but from start to end. So Vc plus Vs, Vc plus Vs is the total volume divided by clearance volume. So it is nothing but Vc, clearance volume. So this is the compression ratio, and this is overall. It is general. It is general. But based on the cycle to cycle, it does not change. But based on the process, the subscript will change. Whether 1 to 2 or 2 to 3 or 3 to 4, that might change. Okay. Now let's put on that here. Vc plus Vs. The total volume of the cylinder. So this is the point 1. So this is V1. Okay, this is V1. And the clearance volume is V2 or V3, because since it is a constant volume process, V2 equal to V3. And I can say that it is V1 by V2. So compression ratio is equal to V1 by V2. So in today's class, we have learned about the compression ratio. And one more important parameter I want to say that, is it one and only parameter impacts on Otto cycle same as in the diesel cycle. We are going to look at the next class. Okay, but it does not, because in diesel cycle we will have another parameter called cutoff ratio. We will have a cutoff ratio in diesel cycle. So what will happen? Okay, so those things will be coming into picture. Then one more thing, important thing is mean effective pressure. The mean effective pressure, in general I will tell you, mean effective pressure is the pressure can be defined by approximate by the pressure mean effective LP. Okay. This mean effective pressure always defined by in general. It is the ratio between the work done to the stroke volume. Work done by the stroke volume. Okay. It is common to all cycles. Okay. Based on that, we can have a relation by means of giving a derivation. You know how to derive work done as well as stroke volume. Okay. So this is a common mean effective pressure, which is a very important parameter to discuss in all cycles. Okay. So once again I will summarize you. In this class we have discussed about the Otto cycle and efficiency, in which the parameter which is very important and affect the parameter of the efficiency is called compression ratio. If compression ratio is higher, what happens? Definitely the efficiency of Otto cycle increases. If decreases, definitely it also decreases. Okay. So compression ratio is significantly play a vital role in Otto cycle, and how compression ratio can be defined, and for Otto cycle how it can be given an empirical relation. Finally, mean effective pressure has been introduced, and generally it can be defined by according to the stroke volume. Okay, so that's all in this class. We will look on diesel cycle also in the next